did immunocompromised mean again? You can't attack, right? So if you're immunocompromised, you can't attack something you should. You can't go to war. HIV is an immunocompromised disease. You can't fight things. That is different from another similar word. The word is tolerance. Can someone tell me what tolerance means in this context? That's my job. You ignore non-self. So it isn't that I can't attack you, I just won't attack you. Okay? This is when the immune system chooses to ignore the presence of a non-self antigen.
Why does it do that? Why does it do that?
That's a good question. Let's think. Well, to understand that one, we have to understand the next one. To understand tolerance, you have to go back to what we learned a little bit last week on allergy. So can someone remember what an allergy was? What did you do in an allergy? When you have an allergy, what do you do? Inflammatory response. You attack a non-pathogen. Okay, what does pathogen mean? A germ, a disease. This is something that's not a threat. So you attack a non-threat. Okay? Also called hypersensitive. So if you have an allergy, you're hypersensitive. You're overly neurotic about things, basically. So to understand tolerance, you have to understand the allergy. So I'm going to show you a little animation about an allergy here. And then that'll help us understand the idea of tolerance. Okay? So let me show you this right here.
Some people develop an allergic reaction or hypersensitivity when exposed to substances such as dust, pollens, animal dander, or penicillin. This hypersensitivity is mediated by IgE. Sensitization occurs when the
IgE does what?
Allergy.
Allergy, because it releases what?
Histamine.
Okay, so we're going to be talking about IG. That's an allergic response. It's when you release histamine. You know, dust, pollen, peanut butter, they're not a threat to you. But when your body assumes they're bad, the body then begins to overreact. And that's called hypersensitivity. That's why you start attacking the peanut butter. You know, peanut butter should be pointless, but you do it anyway.
Do you know why your body decides it's bad?
Yes, it's because you grew up too clean before age of 5. The cleaner your household and the cleaner your neighborhood, the more allergies you get. Hate to tell you. The helicopter parent who bleached everything, bad plan for kids. Because if you don't get exposed, the T cells, which we're talking about, don't know the difference between what's really a threat and what's not. So they attack anything they see. Yes?
With the severe peanut allergies
Yeah.
that like babies would have, is that something different or is that a...
Well, here's the thing. There's 2 ways to test allergies. The one they usually, which is the back pricking thing, is actually inaccurate most of the time. So they found out about 50% of people who have allergies actually don't. And so then if you take that number and look at it further down, very few babies actually become allergic to anything. It's in single-digit kind of numbers. So there are allergies, but it's not as common as people assume it is. Right? And it's almost unheard of anywhere but here. Yeah.
There is new evidence about peanut allergies with babies too, that they've been finding that if you do expose them when they're infants, they don't develop that allergy. So.
Yeah, the idea of never feeding your kids strawberries and peanut butter, right? That leads to allergies. Right? Otherwise, your grandparents would be dead. Right? They don't. So, yeah.
But the other test is with blood. And they
Right, the
test
blood
to
test
see-
is more accurate.
Okay.
But the poke your skin and see a welt thing, that shows you something, but it doesn't correlate to the blood response.
Okay.
So let's go ahead this one. So here's my IgEs, my allergy thing, the peanut butter. There we go.
IgE. Sensitization occurs when the antigen makes contact with some part of the body. The antigen is taken up, processed by antigen-presenting cells and presented on a class 2 MHC to T helper cells.
Wow, wasn't that step 1 through 5 last week? Exactly the same steps. You eat peanut butter, or whatever, peanut butter becomes presented, APC, so your body eats peanut butter, shows it to helper Ts. What are helper Ts going to do when something's presented to them? They're going to give commands, right? I can't talk. Here we go.
Tissues under the mucous membranes are rich in B cells committed to IgE production, and IgE-producing cells are more abundant in persons susceptible to allergies. The T helper cells produce cytokines which stimulate these B cells to proliferate and differentiate into IgE-producing plasma
Are
cells.
those steps? You clone. Right? They all look the same. And they're going to flood you with antibodies.
As IgE is produced in specific areas of the body, the IgE molecules attach via their constant regions to receptors on nearby mast cells. Mast cells contain granules packed with chemicals that induce a hypersensitivity response. Once attached, the IgE molecules can survive for many weeks. The individual is now sensitized to the antigen. When exposed to the antigen for a second time, the antigen binds to the IgE antibodies on the mast cells. To trigger a response, 2 cell-bound IgE molecules must react with a specific antigen. Within seconds of the reaction, the mast cell releases histamine and other mediators of the inflammatory response from the granules, triggering a variety of symptoms.
So remember, histamine makes things big and leaky. Your capillaries get big, all this fluid. So if this is in, remember IgEs were in your respiratory tract, the skin, so your skin's getting bloated, you're getting fluid, you're getting a bunch of snot, and you call that I'm allergic. Because you're flooding those body parts with a bunch of fluid, makes it itchy, makes it painful, and you call that being allergic. But you're simply doing histamine in those areas, like your skin. That's an allergic response. You're overreacting to peanut butter. So you normally shouldn't care, but you decide to care. That's an allergy. You're oversensitive. Right, so let's go back here and figure out on the board what determines if I'm tolerant, meaning I don't attack something, and I'm allergic, and I do attack something I shouldn't. Who do you think makes that decision of what to attack and what not? Which T cell? The helper T cell. Your helper T cells decide if it doesn't want to attack something or it does. They make the commands. So if you're allergic to peanut butter, you can blame your helper T cells. They're giving orders to attack peanut butter, and they shouldn't have done that. Okay. Yes?
What about seasonal allergies? Like some people get it out of the blue.
Kind of that same thing. One day your helper T cells wake up and say, I really hate grass seed, so I'm going to order the immune system to attack grass seed, or cherry pollen, or ragweed, or your dog, or your cat, or whatever. It's this distance here. Right? Make sense? So if you go to an immunologist and say, I would really love to eat peanut butter again, they're going to do tolerance training. So how do you think they convince you to become unallergic with tolerance training? What cell do you think they're trying to train? The helper T cells. If you go for training, quote, quote, they're trying to convince your helper T cells not to attack the allergy, but instead tolerate the allergy. Right? And most kids who have peanut allergies can be taught to tolerate it over time. Don't do that at home. You can kill the kid. Right? But with an immunologist, they can train your helper T cells to ignore the peanut butter eventually. It works about 70% of kids. Right? But you have to teach the helper Ts that I don't care about peanut butter anymore. Right? Make sense? I think I mentioned this before. Do you know I'm a beekeeper? I keep bees. Do you know that? Okay. Rule of beekeeping, you always get stung a lot. That's actually a rule. Can you guess why I constantly, besides I'm an idiot, why I keep getting stung? Can you guess what I'm trying to do with my T cells when I'm constantly getting stung? I'm training them. The more I get stung, the less I get histamine. It still hurts. Don't get me wrong. It always hurts to get stung. A lot.
You just
But
don't get the response.
the more I get stung, the more my brain assumes I guess that's okay to get stung every day.
I'm not dying from this.
I'm not dying. Bee pollen, bee venom hurts, but it's not going to kill me. So I become very tolerant. The first thing of the year, I welled up. by the 100th thing of the year, whatever. Still hurts, I still cry, but I don't swell up. All right? Worth the sugar, you always have someone with you for that first thing, because if you became allergic over the winter, you die. Right? So you always have someone with you while you get stung. Right? You put the bee on you and you tap her and she stings you, and then that's how it works. Or you just be an idiot, put your hand in there and let it go. Right? That's fun. Yeah.
So you're not making a bunch more memory cells with each exposure?
No, in tolerance, you're not making memory cells with each exposure. So with tolerance training, you may have memory cells, but the helper T cells taught not to turn them on, the ones you already have. So you're trying to basically shut off the immune response past the helper T. So you get the APC, but you don't get anything else. Yes?
So by the end of the season, you don't even swell up?
No. Unless it's on your face. The face always swells. And you look like some weird...
What does it look like? Does it
Just gets red.
weird?
It itches. But you don't get that.
So do you have an EpiPen with you always?
No.
Just in case?
Not at all. I guess, well, I guess my wife will get the life insurance that one day when I just don't have. So I'm okay. I don't have a whole lot of hives, so I don't get stung like millions of times, but I get stung a lot, so I'm not real confident, right?
Can you explain why memory cells aren't being formed in tolerance?
Well, if you're tolerant, you don't attack anything, so your body wouldn't even make memory cells the first time.
Okay, so tolerance can't happen in a person who has an allergy.
But if you do have an allergy, you've already made memory cells, but the helper T cell will then not order them to come on. You never get to your immune system, you never saw it if the helper T cells never give the command. So even though you have the memory cells, they wouldn't know to do anything. They would not be told to come on.
Is it more about like the frequency of exposure, or like an early decision made by your helper T cells about whether they're going to be tolerant or sensitive?
That's the question we don't know. So I'll show you the one data that shows you don't like this graph. Remember autoimmunity? What's autoimmunity about again? You do what?
Kill yourself.
So if you look at autoimmune disorders, which is not the same as an allergy, but it's similar, worm infestation, autoimmunity. Do you see a pattern?
Whoa.
They're opposites, right? So the logic is the cleaner you live, the more likely your immune system gets it wrong. Because here I'm really going to die unless I kill the right thing. Here I don't know what the right thing is, so I might as well kill that too, right? So autoimmunity and allergies go along with cleanliness. It's called the hygiene hypothesis. So the dirtier your life, the less immune problems you have. You still die of other crud, but you don't get immune problems.
Why is it so moderate in Australia?
I have no idea.
Probably other snakes and spiders.
Aussies, I don't know. I don't know why, why is that one like that? I don't know. I mean, but the trend's there. In Japan, I don't know.
Basically what you're saying is autoimmune disorders because your body is like, I need to do something with myself,
Right.
and since you have nothing else, I'll just kill you.
Exactly right.
Yeah.
And if you have a bunch of army troops there, they want to shoot something, right? So if you don't give them a real disease, they'll find one like peanut butter for them.
Wow.
That's called the hygiene hypothesis. So the dirtier your life, the less autoimmune and allergies you get. That doesn't, you still live in squalor, but if you go to a missionary trip, most people have never heard of allergies in the third world. They don't even know what that is, because it doesn't happen. It happens here, because we're cleaner. They're living in squalor, they're going to die of other things. But I'm not saying, eat sewage, but send your kids outside. Have a dog, do something. That's the logic. Right?
Is that a particular parasitic?
Get rid of the bleach, damn it. Make sense? Okay, so if that made some sense, we're going to do our last little thing in the packet here. Time for flu. It's flu season.
It's immunity. No, this was in our packet.
All right, 5 base 31. We're going to start on question 2. We're going to skip question 1. Let's go question 2. Remind me again for your final exam what an antigen is. A shape on a cell, right? The marker, receptor, protein. So that's the big idea again. The antigens are shapes on a cell. How does your immune system know the antigens? How does it know that?
Helper T cell.
The helper T cell, right? The helper T, its job is to look at your shapes and say, is that me or not me? right? Which one are you?
It's
That's that
the bouncer.
presentation. Hmm?
It's kind of like the bouncer.
Yes, it is. Right. Bouncer, checking at the door. So now we have antigens on the flu, because flus have shapes as well. So does anyone know the 2 letters for the flu antigens?
H and N.
H and N. Very good. So give me a flu name like what?
H1N1.
Congratulations, you're talking about the antigens on the surface of the flu. That's the shapes of the flu. So where would they be located if they're antigens? On the surface of the cell. Short chain is true. The surface of the virus. So every living thing has shapes, and the virus has H's and N's. Make sense? Now the big word here, antigenic shift. Does anyone know that word from biology 102 or 112? It is a mutation that makes your antigens do what? Shift, which means change.
New vaccine every year.
So antigenic shift means you change your antigens. Your antigens have varied or changed or altered. Okay? So I'm going to show you some pictures of antigenic shifting in a nice way. Okay. I lost the mark. I lost the picture. There it is. Oh. All right. So this green ball of fun, this is virus, flu. The H and the N stand for those chemicals you do not have to know in this class. Take micro, you do. But this would be H1N1. The number 1 H and the number 1 N are on the ball. Those are the antigens on the outside of the flu virus. Okay? Look at this one on the right. Do those look the same?
No.
No. So what happened to this one?
Red.
It had a shift, we call it. It's changed or altered its antigens. So anytime the antigens change, we can call it a shift. It's altered. So take a look at this one. Another shift. This is more shifted than this one. It's not even English. I don't know what that means. Right? More shifty. So then what's going to be the next one? How are we going to shift again? Super shift, right? We don't know. That's the problem of the flu. Also, HIV does this. The reason there's multiple HIVs and flus is because they keep shifting their shapes. So if you were a memory cell for the green spots, and you see this one, what do you say? That's totally new. I have no idea what that is. So if I don't remember what it is, what do I have to do now? I have to restart the whole 2-week thing and do it again because I don't remember those shapes ever. So the idea of memory is it has to be the same antigens. These are not the same. Memory doesn't work. So every time you shift, it's a new beast. You got to learn a new skill. Right? So antigenic shifting is what viruses do to go from H1N1 to H5N1. Right? That's a shift, and that number changes. Make sense? That's shifting. All right. So if you understand what a shift is, you're changing your antigens. Let's go down and read about the flu shot. Did you get yours? Nope. Ah, no, you losers. All right. Hey, let's answer some questions. What are the components of a yearly influenza vaccine? What do they put in the vaccine to have you remember the flu? The antigens. H and N antigens. They're putting those shapes into the vaccine. Again, micro, they go through a little more detail. So they're going to give you H's and N's in the shot, so you'll remember it and build memory cells, right? Your friend, Portland, they don't take shots, but they got a shot and they got a flu anyway. So how could you get the flu if I give you the shot?
Mutation.
It's not the same strain.
Okay, it could be a different strain. In other words, they're different shapes. So remember the new one. What else could be happening if I get the flu after I get the shot?
It causes it.
It doesn't actually. That's what everyone says.
Tell that to anti-vaxxers.
What is it?
Tell that to anti-vaxxers.
Right, people don't say science anymore. What is it? Didn't work. That's in some people. The more likely is you had the flu already. Okay, Okay, you work in healthcare. When do people visit the doctor? After they're sick, right? When do people get the shot? When they're already feeling symptoms. How long does it take you to get a shot to a memory cell? First time? 2 weeks. You got the flu, you go in, it's not magic. It takes 2 weeks. So you're going to have the flu already, then get the shot and complain. It's 2 weeks later. So the most common reasons was the wrong flu shot, or you waited too long. The most common reasons you get the flu once you get the shot. This is actually the most common, right? Right, so here's the problem. Other things can also catch human flus. Does anyone know the 2 other species that can catch human flus? Pigs and birds. Yeah! Pigs and birds. All right, so pigs and birds can harbor human virus. So if you put pigs and birds and humans together, what do you think would happen? Mutations or antigenic shifting, right? I have that picture. Right. You want the pretty picture or the scary picture?
Both.
Okay, I'll give you the not so scary first, and then I'll give you the scary one later. All right.
There'll be a helicopter teacher.
All right. Say hello to Asia. So on the left, we have various waterfowl, chickens, whatever. There's Mr. Piggy down here. And here are the viruses. Notice they're all different shapes, because they're different viruses. But they can mix together, especially Mr. Piggy, right there. And then look what pops out. That is not that. So look what the people got. They got that. Is that the same as that? Congratulations, antigenic shift. So by putting pigs and birds and people together, the virus can reassort or shift more than if it was by itself, because there's more choices between the different viruses. Right? So hence, when you think about history, they call them what? Swine flus, bird flus? That's the logic. That's where you got it from, the swine or the bird. That's where flus come from. Right? So as I put these three things together, I get more shifting. Right? So let's do that. Let's put the scary picture up. Someone say yeah. All right. So we have 3 choices here. One is the bird flu gets in you and you give it to your neighbors. One is the bird flu gets in the pig and the pig gives it to you. Or this one's the worst. The bird and the human go in the pig and the pig makes something that's neither one and you get that one.
Oh.
Right? So all those show, this one especially shows a rapid antigenic shift. That is not those. Right? That's the problem with pigs and birds and people together. Right? That's the shifting mechanism. Make sense? So pigs and birds harbor flu. So the potbelly pig backyard chicken thing in Portland, think about that for a minute. Right? Right. Let's go back to our case study. So go back to the next page. The avian flu. So this, you can read a little blurb about avian flu, but we'll go right to the questions. What made the avian flu worse than all the other flus? Why are they so bad? What do they call it when you have a really bad flu?
Epidemic.
Epidemics, that's right. These cause epidemics. These spread really fast, really badly. And that leads us to this one. Why does those make your immune response different? Okay? The magic answer is cytokine storm. I love that word. Okay, so to understand cytokine storms, I have to walk you through cytokines. Okay? So, ready? Let me show you some pictures of cytokine storming. Is that even a verb? It is now. All right. I'll put it right here. Okay, we're going to start at the upper left. Notice this is H5N1. Somebody knew it shifted. This is your body barrier. Remember our first level of defense was barriers. So if some homeless guy sneezes on you, poof, here it goes through your nose. Here's our APC step. Remember, we eat it and then display to the helper T cell. The helper T cell then does its job. This is new. Let's turn on the immune system. But look at this. I love this phrasing here. Uncontrolled exuberant immune response. What does that mean, really? Exuberant means
Happy.
like really gung-ho, and uncontrolled mean way too much. So you're really gung-ho, you overdo it, you go nuclear, right? So your immune system overreacts, goes nuclear, goes Rambo, and then orders the T cells to start attacking the flu. Where does flu usually live? In your lungs. So look what happens to your lungs if I really attack them. Blurry, I know. What happens? What happens to your lungs? You're killing them, right? You're shooting holes in your lungs. What happens to you when you kill your lungs?
Can't breathe.
You die. That's the problem. So your cytokine storm is you overreacted and killed your own body to the point of killing you. You have a storm of cytokines. Right? You overreact, you're over-exuberant about attacking. So the problem with these weird flus, your body overreacts because it's never seen it before. So if you look at the things on the right, cytokine storm. The immune system overreacts to the pathogen, and that tells your body to destroy your organs. That's the storming. It's too much of a good thing. Right? So if you know about your 1918 flu, that's what happened. Right? Makes sense? So the problem with these weird flus, your body overreacts and kills you, trying to get the virus dead. Right? So if we go back to our little case study. So what is a cytokine storm? What is it? Uncontrolled exuberant. Yeah, I love that. Let's do this. That's uncontrolled exuberance. Is that right?
I think so.
Yeah! All right.
That's melted.
It's an overreaction. You're causing you went nuclear. You went too far on your immune response. And why is that fatal? What will it do to your organs? Kills your organs, destroys your own organs. To save the village, we had to destroy it and we dropped an A-bomb on it instead. That's the logic here. So worthless trivia, in 1918, the youngest, healthiest people are the ones that died because they had the best immune response. So their immune system could destroy themselves better than the sick people, which is the opposite of what you think would happen. So let's do this one here, number 4. How can we keep getting H1N1 pandemics in the same century? It could be a shift. It could be different. Right? It could be loss of memory. It goes away so you don't remember it anymore. Or it could just be beats us. Right? No one knows why these things pop up. Right? So the 1918 flu happened for some reason, then went away for a while and came back in 57. Right, yes?
So is this pretty much the same thing as autoimmunity, or are they two different concepts?
They're different concepts. Autoimmunity, you intentionally target your own tissues to kill them. You see them as foreign. Here, the body knows the difference between you and not you. But to kill the virus, it kills your own cells too far. So it's the same overall end game, but it's not the same reason. You're not intentionally targeting your own cells. Yes?
So you kind of want like a mediocre, like a decent immune system. You don't
Yes.
want it to be too good, and you don't want it to be bad.
That's right.
So that you can
You want
survive
to
all the
see
time.
average on your immune system. Because if it's too bad, then I get something like over there. If it's too good, I kill my own body. So you want just enough to stay alive, but not so much that you kill yourself. All right? So let's see, number 5. I'm going to mix a swine flu with an avian flu. H1N1 plus H5N1 makes what?
Super flu.
Super flu. Because the answer is we don't know, because they're going to do a shift that we don't understand. So you're going to get something that isn't really either one. right? All right, so I'm going to get something that I've never seen before. So, our last question for tonight is this one. You read through this stuff, humans have a 2,6 receptor, right? Birds have a 2,3, and Mr. Piggy has both. So tell me about Asian countries. What 3 things are in Asian countries? Lots of
Birds.
people, birds,
Okay.
and pigs. And you mix those together, and what are you going to do? You're going to shift your antigens. So in case you know your flu biology, flus start in Asia. And so the CDC goes to Asia in their flu season, tries to guess what magic shift it will be, flies to Atlanta, 3 months later cranks out a vaccine they hope will match what this will be. And they sell it to you. That's how they work. So all flus, we believe, start in Asia because you have 1 billion people with 5 billion birds and pigs.
Is this the birds and pigs in urban areas?
Yeah.
Instead of.
Right. The more
We
crammed you
normally
put them,
farm in the rural
Right.
areas, and so it's separated.
that's right. The closer you are together, the more the virus can shift easier than if you're, yes.
So every year they get somebody on the radio who's a flu expert and they say, it's inevitable, super pandemic is gonna kill us all.
Yes.
But it never doesn't happen.
Right, because they don't know what reassortment will be. So it could happen every year, but they don't know. And they also know that it will happen, there will be a flu every year. So they're guessing, is
But
this
the-
year a bad one?
The guy on the radio who says the super flu will kill us all one of these
Well, it
days.
will eventually, always is, yeah. Right, but you don't know when it'll be, this is Vegas. You don't know which of those shapes will arrive. Right. Make sense? Yep.